Good afternoon. I was very fortunate to spend a lot of time outdoors as a child, and these woods were my backyard. When I go back now, the woods and the stream are still there. I recognize individual trees as if they were old friends. Very little has changed, and actually any change would feel like a real loss of the sense of place that I felt as a child. That spirit lies at the heart of American conservation. We look to our parks to capture nature as it once was, unimpaired by human activity, and set aside in the public trust for the enjoyment of all. But nature and ecology and history teach us the inevitability of change. We can see this in the drought that gripped California in recent years. Record low rainfall, unusually warm temperatures left the mountains bare. California's cities and agriculture vulnerable without the melting snow that feeds the water supply in summer. An estimated 100 million trees have died in the mountains. Here at Berkeley, we've been studying the impacts of the drought on California's native oaks. We deploy state-of-the-art techniques to see how water stress impacts the plant's internal plumbing system and better understand why some trees were vulnerable to the drought and in the future which trees may be threatened. So how are these kinds of environmental changes going to play out in the future? To answer this question, we look to the past. Here at Clear Lake, north of San Francisco, the trees up on those hills shed pollen, it comes out, it falls on the lake, it settles to the bottom, and over time leaves a signature of vegetation change as one layer stacks on top of the other. Berkeley scientists have cored the lake to obtain a high-resolution record of the pace and timing of those changes. Back at the height of the last ice age, those mountains were covered in pines and other conifers, needle-leaf trees that are adapted to the cool conditions. And over the space of a few thousand years, they were replaced by oaks. But where did those oaks come from? They may have been found further south, along the coast where the temperatures are buffered by the cool waters of the ocean, or perhaps on south-facing slopes protected by the warm sun in little pockets on the landscape. In each generation, an acorn is picked up by a squirrel or a woodpecker and taken a half mile, maybe a mile. The acorn germinates, the tree grows. A couple decades later, the process repeats. And over long periods of time, the species can shift across the landscape. In the 21st century, we face an era of unprecedented environmental change. The emissions of CO2 from fossil fuels, from deforestation, and from land use change are accumulating in the atmosphere and driving this rapid period of climate change. So how fast will plants and animals need to move to keep up with this changing climate? We can visualize this by calculating something we call the velocity of climate change. It's the speed at which the conditions move across the landscape. It's the speed at which you would have to move to keep up with the average climate over time. And in large flat regions like the Midwest or the Central Valley, these speeds can exceed 5 miles per year, or they are projected that they may exceed those speeds in this century. And that is faster than most all species will be able to move and establish viable populations over time. But you also see the blue areas on the mountains. Mountains, actually, these velocities are much lower because the animals and plants don't have to move as fast or as far as they move uphill to offset changing conditions. And this simple fact underlies one of the key principles of conservation in the 21st century. Variable landscapes with ridges and valleys, south-facing slopes and north-facing slopes, different kinds of soils, create a patchwork of conditions in close proximity and allow species with different ecological requirements to coexist on the landscape. And this diversity has twofold value. The first is that species don't have to move as far to find suitable conditions. So in periods of change, a small shift on the landscape may be sufficient to offset even what could be some marked periods of climate change. And more importantly, in the future, at least some of these species are likely to have the adaptations to thrive under future climates. We can also take steps to help these plants and animals move. So wildlife crossing structures, such as this one, are being built at pinch points across highways all around the world. But at a larger scale, we need to establish better corridors that connect up parks and open space across climate gradients, linking warm places to cool places to allow plants and animals to make the kinds of shifts that will be necessary. But what if this isn't even sufficient? Some species may not be able to move fast enough. Will we move them? Assisted migration is the kind of strategy that is now under discussion that in the past might have really been thought to be sort of outside the fold of conservation. And it may be the only path to success for some species, but we also know it brings with it the possibility of unintended consequences and ecological surprises. Parks and open space form the nucleus of conservation of our native plants and animals. But a park is not an island, and our success in the future will depend on deploying novel strategies to ensure the conservation of our precious heritage in the face of rapid environmental change. Thank you very much.